Hi, and welcome to my channel. Today we're going to talk about a compressed air supply for your home or garage. It's a perfect DIY project, and it's not that expensive. So we're going to discuss a variety of things such as types of compressors, what kind of compressors are good, which kind of compressors you should avoid. We're going to talk about the piping, how to distribute it through your house. We're going to talk about connections, metering, and how to use it with blowguns and nailers and other compressed tools. The reason I did this, started this project, is I used to buy a lot of these compressed air dusters, and I got tired of buying them. They got expensive after a while. And plus I did want to use compressed air to use my nailers in the shop here. So hopefully you'll get some information out of this. If you have any questions, let me know at the bottom. And let's get started. Okay, this is the first compressor I bought. This model's from Harbor Freight. Its brand is Central Pneumatic. It is a 3-gallon pancake compressor because of its shape, and it can handle or pump up the tank to 100 psi. As most compressors, the left-hand gauge talks about or shows you the tank pressure, and the right-hand gauge shows you the pressure going to the tool, and you adjust it with the knob you see in the center. I didn't pay much for this. This was on a super sale. I think I paid $35 to $40 for it. But the problem with this first compressor I bought was it was loud. When I had this in the basement, it was so loud you could hear it everywhere in the house. So I just relegated this to the garage where it is to pump up tires and stuff like that. So I wouldn't recommend a very loud compressor like this one, even though it was cheap. Okay, this is the second compressor I bought. This was also purchased at Harbor Freight. It's called a Fortress Ultra Quiet, and it is much quieter than the previous compressor. It's got 2 gauges as well. It has 135 psi capacity. It's only a 2-gallon, and I set the knob for the output to the tool about 90 psi because that's about all I need. It was a lot more expensive than the previous compressor. It was about $159 I think on sale. It might have gone up since then at Harbor Freight, but again, it's very quiet. I wanted to mention about the Fortress compressor. Both it and the previous compressor I showed you had short cycling, and that means when I turn on the tool that I was using or use a little bit of air, it immediately comes on, and it turns on and off even if you're using a little bit of air. So I decided to add this. This is a 7-gallon pressure tank, and I bought it from Lowe's, and it came with the gauge you see here and some fittings. And the way I've got it hooked up is the output of the compressor goes through this orange pressure line and then connects to the cobalt. And what happens in the pressure tank is it builds up the pressure in the 7-gallon tank to about 90 psi, and then when I turn on a tool or use a nailer or take some air out of it, the compressor doesn't immediately come on. You have to reduce the pressure in the pressure tank by a significant amount before the compressor comes on. So I hooked that up, and I will show you the configuration next. Okay, this is the configuration we have so far. The picture here is of the Fortress compressor. That's a 1-gallon model, but I'm using the 2-gallon, and that's the one I recommend. It has more standard cubic feet per minute as well, more air volume. So over on the left is the power switch, the tank gauge. The tank pressure is not adjustable. It goes up to about 120, 130 psi. The regulator knob controls the output pressure right here, and there's 2 air outlets. So that feeds the cobalt tank, the 7-gallon tank. There's a pressure gauge here which should read the same as the output gauge on the compressor, and then the output goes to the tools. Now, one thing I want to mention also is the advantage of having this 7-gallon pressure tank. As I mentioned before, it prevents the compressor from cycling on and off frequently, which could lead to overheating and the compressor to shut down. So it's a good thing to have. It's I didn't think I mentioned it before. Believe it's around $80 for the pressure tank. Also, both the pressure tank and the compressor have drain valves. As you use this over and over again, the air in there has moisture in it. The moisture condenses and can cause rust to form. So periodically, you should drain the compressor and the pressure tank as well. This is the configuration I want to get to. I want the output to go to my lab and workshop, and each location have a tool connection and a drain plug. Also, I've extended the line to an expansion stub for future expansion of the system, which I will show you later. So this is where the pressure hose goes from the pressure tank into the distribution for the rest of the house. And you can see down here there's a drain, just like I mentioned on the pressure tank and the compressor. And then the air pressure goes up, the air goes up to the ceiling and over into the next room, which happens to be the lab. So I'll show you that next. So we're in the lab now, and you can see I have a suspended ceiling, and the copper tubing goes across the top of the lab inside the above the suspended ceiling, and then it comes down into this vertical run. It goes down here and connects to the tool. In this case, it's just a trigger device that blows air, and below that is the drain that you can let the water out, as I mentioned before. Now, I don't have any pressure regulators here as some systems have, because this particular trigger device, it has an adjustable nozzle on the front of it, you can see, which gives you a real adjustable flow of air from almost nothing to full blast. So that works for me. I clean circuit boards with it, dry off circuit boards, and other miscellaneous stuff like that. And it works pretty well. Now the other connection for the workshop is right here. It comes from behind the wall. And on the other side of the wall is a drain as well. And there's a hanger here for the hose, which I just took off so you can see it. So here's an extension from the pipe, that copper tubing, that's going to eventually go through the ceiling here and over to my model train layout, where I'm constantly needing a small amount of air to blow dust off the tracks and the layout itself. So that's for a future expansion. Okay, let's talk connectors. This is just a few of the connectors I have. These are 1/4 inch, and they're called, this one's called 1/4 inch male brass industrial plug. I would just make sure that when you buy these connectors, these are the male ones, but you buy the female ones and the male ones, that they fit together. For example, this one here is a 1/4 inch, but it has an O-ring. And I would make sure that the female part that goes into this accepts O-rings and doesn't have a problem. Also, when you make a connection with these, what I do is I typically first wrap them in Teflon tape, but I don't just rely on the Teflon tape. After I wrap them with Teflon tape, I smear them with this Teflon paste thread sealant. That's one thing you can use. Another one is this T+2. It's also Teflon enriched pipe thread sealant. So I use the pipe thread sealant on the Teflon tape after I've wrapped it to make sure I get a real good airtight seal. And that seems to have worked for me. And you see here is the female equivalent of the 1/4 inch nipple. Goes in there like that. And I've had a leak on this one, and I think it's because I didn't use thread sealant right here, just Teflon tape. Another thing I wanted to mention is this product called Snoop. You can use this to detect leaks. It's kind of like a soapy solution, but it's not water-based. It's non-toxic, non-corrosive, and non-flammable. And it, like I said, it doesn't cause any rust or anything because it's not based on water. You can get this on Amazon, and I found this to be a great help. I found leaks I would have never found otherwise. Very slow leaks that were causing the compressor to come on and off more frequently. So it's called Snoop, and like I said, it's available on Amazon. Okay, let's do a quick tutorial on soldering copper tubing. First thing I'm going to do is clean the end of the copper tubing. This is 1/2 inch, and you just use some coarse steel wool like this, and make sure it's really good and clean. And that looks pretty good. The next thing I'm going to do is clean the fitting. This is a brass fitting I have. I don't have any copper ones, but principle's the same thing. You clean the inside of this. You can use steel wool, or they make brushes like this that'll do something that will do the same job. Basically a wire brush inside. You can get them for 1/2 inch or 3/4 inch fittings. And clean both sides of it really good. That looks pretty good. And next what I'm going to do is I'm going to put some paste on the fitting and the tubing. Okay, here's the flux. And now we're going to put some on the fitting that I just cleaned. Inside both sides. Both ends of the tubing, of the fitting. And then put the fitting on. And I'm not going to put the other end on right now, but because the principle is the same. But I'm going to heat it up using the solder. So a couple of points. You want to heat the part where you want the solder to flow into. So I'm heating this, and I don't want the solder to directly touch the flame. Okay, that's done. Now, last thing you do is wait until it cools down a little bit, and then take a cold cloth and wipe it clean. That'll take the flux off it, the remaining flux, so it won't corrode. Like that. It won't corrode the pipe, and it won't turn green, the copper green, like you've seen it. Okay, now if you look at it, you should have a seamless bead around that joint, and I do. So that's it. That's all there is to it. And I'm going to put the next one in here after I turn off the camera and extend this pipe because I need a longer copper tube. So that's about it.